Good day everyone, I am teacher Rovi and today I'm going to discuss about the nomenclature of acids. Alright, so first let us define what is an acid. An acid can be described as a substance that yields hydrogen ions when dissolved in water. Hydrogen ion is equivalent to one proton and is often referred to that way. So, all acids contain hydrogen atom in their formula because acids yield hydrogen ions when dissolved in water. Now, let us talk about the properties of acids. Let's recall the things that you know about the properties of acids that were discussed during your previous grade level. Okay, so we know that an acid tastes sour. Alright. But of course, it is not advisable to taste any acid that you used in your laboratory experiment. So aside from this, we also know that the pH of an acid is less than 7. Also, we have this acronym BRA. Alright? Whereas blue litmus paper turns to red means the compound is an acid. Alright. Aside from that, we also know that acids are corrosive. Alright? So, these are some of the basic properties of acids. Alright. Now, let's proceed with the nomenclature. Okay. So, let's discuss first the oxoacids. Alright. So, from the term itself, oxo, alright, from oxygen, alright, and acid. So these are acids that contain hydrogen, oxygen, and another element. So usually the central element are chlorine, iodine, nitrogen, bromine, carbon, sulfur, boron, or phosphorus. Alright, so again, oxoacids are acids that contain hydrogen, oxygen, and a central element. The formulas of oxoacids are usually written with hydrogen first, followed by the central element, and then the oxygen. Alright, so these are the common oxoacids. Alright, let me just clear everything. Alright, there you go. Okay, so again, these are the common oxoacids. I would like you to memorize this. How many are they? 7, 1, 2, 3, 4, 5, 6, 7, 8. Alright, these 8 oxoacids so that you will not have difficulty in navigating the diagram that I will discuss later. Alright? So, I call this the ic acids. Alright? Because, if you notice, HClO3 is called chloric acid. HiO3 is called iodic acid. HNO3 is called nitric acid. HBrO3 is called bromic acid. H2CO3 is called carbonic acid. And H2SO4 sulfuric acid. H3BO3 boric acid. And H3PO4 phosphoric acid. sometimes in chemistry, there's no other way to learn but to memorize some of the references. Alright, so I want you to memorize these ic acids so that you will be able to navigate properly the diagram that I will show you. That will help you in naming acids. Alright, so again, so that you can memorize chloric acid, HClO3, iodic acid, HiO3, nitric acid, HNO3, bromic acid, HBrO3, carbonic acid, H2CO3, sulfuric acid, H2SO4, boric acid, H3BO3, and phosphoric acid, H3PO4. Alright, now let's proceed with the next one. So again, they are the oxoacids, specifically the ic acids. Alright, now, alright, these are the ic acids that I mentioned a while ago, right? Okay, so I want you to look at the diagram. Okay, let me just adjust. Alright, the frame. There you go. Okay, so these ic acids will serve as our reference point. Okay, when you say reference point, it's where we're going to start. Okay, so from the ic acid, if we add oxygen in the formula, one oxygen in the formula, it will become a per-ic acid. From the reference, if we remove one oxygen from the formula, it will become an ous acid. And then, from the ous acid, if we remove another oxygen from the formula, it will become a hypoous acid. Alright, so for you to understand what I am saying, let's have an example. So let's take chloric acid. Okay, so that is our reference, ic acid. Okay, so let me write the formula first of the ic acid. That is HClO3. Okay, we call this the ic acid or chloric acid. Okay, so this is chloric acid. If we add oxygen, one oxygen atom in the formula, it will become HClO4. Okay, so from 3, it became 4. Okay, so because of the addition of one oxygen atom in the formula. Now, from chloric acid, it will become perchloric acid. Alright? So again, from chloric, an addition of one oxygen in the formula will become, it will change the name into a perchloric acid. Okay, perchloric acid. Okay? So, the formula is per-ic acid. A prefix per and a suffix ic to the root term. Okay? Now, let's go back to our ic acid. We have chloric acid. This is our reference. Okay? This is our reference. Okay, so if we remove one oxygen atom from our reference, which is chloric acid, it will become HClO2, right? So from chloric acid, it will become an ous acid, and the name would be chlorous acid. Okay, chlorous acid. There you go. Okay, so again, from HClO3, we remove one oxygen atom in the formula. making it HClO2, and the name would be an ous acid, which is chlorous acid. Okay? Alright. Now, from an ous acid, if we remove another oxygen atom from the formula, it will become HClO. Okay. So, if it is HClO, it is an hypoous acid. So, what will be the name? That would be hypochlorous acid. Hypochlorous acid. Alright. So, did you get that? So, again, our reference here is the ic acid. Okay. So, HClO3 is our chloric acid. If we add one oxygen atom to the formula, it will become HClO4. And the name will become perchloric acid. Peric acid. Okay? And then, from our reference, which is chloric acid, if we remove one oxygen atom from the formula, it will become HClO2. That is called chlorous acid, an ous acid. Okay, and from an ous acid, if we remove another oxygen atom from the formula, it will become a hypoous acid. So the name will be hypochlorous acid. Okay, so I hope you got that one. So now, alright, removal of all hydrogen ions. So again, we call these acids, the peric, ic, ous, and hypoous acid, we call them oxoacids. Alright, because they contain oxygen, hydrogen, and a central element. So again, we write first the hydrogen, the central element, and then the oxygen. Alright. Now, if we remove from the formula all the hydrogen atoms, it will become an oxoanion. Alright? So, if we actually dissolve these acids in water, they will yield the hydrogen ion. So, it will be removed from the formula. Okay. So, therefore, if these acids yield all the hydrogen ions, then what will be the chemical formula for the oxoanion? Okay. Now, let's remove all the hydrogen atom in the formula. We have HC. Let's start with our reference ic acid. Okay, so from chloric acid, let's remove H from HClO3. So that will become ClO3. And since it is an oxoanion, an ion means negatively charged ion. So therefore, we will write here a negative charge. Oops. There you go. Okay. So that is one negative. Okay. How will you determine how many negative what is the net charge for the anion? Okay, you will determine that based on how many hydrogen ions were removed. Okay? So, because we only remove or the acid only yield one hydrogen ion, therefore, the charge would be one negative. That is just an easy way for you to remember. Alright? So, the number of hydrogen ions somewhat represent the number of the negative charge as well. Okay. So, we have chlorate. Okay. So, this one will become chlorate. So, again, from the ic acid, chloric acid, if you remove the hydrogen, it will become chlorate. So the formula, for the formula, HClO3, it will become ClO3 negative. Okay. Now, if we remove the hydrogen atom from the formula in the perchloric acid, it will become ClO4. Again, what is the net charge? It is also 1 negative. Okay, let me write it. Okay, 1 negative because we only the acid only yield 1 hydrogen ion. Okay, so it will become ClO4 negative, or we call this perchlorate. Okay, so from 8 ion, if you actually add 1 oxygen atom to this formula, it will become ClO4 negative, and that will be a perchlorate ion. Okay, so now let's proceed with the chlorous acid. Chlorous acid, the formula is HClO2. Okay, if we remove the hydrogen atom in the formula, it will become ClO2 negative, or this is an 8 ion. So the name would be chloride ion. Okay, or simply chloride. Okay, now from the hypochlorous acid, if we remove the hydrogen from the formula, it will become ClO negative, and this is called a hypoite ion. So this is hypochlorite ion, or simply hypochlorite. Okay, so I hope you got those points. So let me also reiterate some things. Okay, if you notice, we have the same process. From the ic acid, if you add 1 oxygen atom, it will become a per-ic acid. So chloric becomes perchloric. Now, from the 8th ion, if you add 1 oxygen atom as well to the formula from ClO3 negative, it will become a per-8 ion. So ClO4 negative. Okay, so there is an addition of 1 oxygen atom in the formula. Okay, so from 8 ion, if you remove, so this one, addition of 1 oxygen atom. Now, from 8 ion or chlorate, if you remove 1 oxygen atom, okay, it will become an 8 ion. Alright, so from ClO3 negative to it will become ClO2 negative, or chloride ion. Okay, so from 8 ion, if you remove again 1 oxygen atom, it will become ClO negative. So that is the hypoite ion. So the name would be hypochlorite ion. Alright? So I hope you got it. Let me give you another example, okay, for you to remember. Let me just erase the annotations for this. Alright, let me erase. Okay, wait a minute. Alright, so let's say okay, so let's say I have the ic acid, nitric acid. Let me just annotate again. There you go. Okay, so this time let's have another example. Let's use HNO3. HNO3. And since it is an ic acid, this is named as nitric acid. There you go. Alright, nitric acid. So, if I remove one oxygen atom from the formula, it will become HNO2, right? Okay, what is the name of this acid? So from ic acid, it will become an us acid. So therefore, the name will be nitrous acid. Okay? Alright. Now, another example. Let's have sulfuric acid. Okay. So, sulfuric H2SO4. Okay, let me just erase again some of the things that I've written. There you go. Okay. And annotate again. Alright. So, H2SO4. Okay. If I remove one oxygen from this formula, it will become H2SO3. So, from sulfuric acid, it will become sulfurous acid. Okay. So, now, if we proceed this way, or if we form the oxoanion, if we remove the hydrogen atoms from the formula, it will become SO4. Since hydrogen ion were yield, it will also tell you how many or what is the net charge for the anion. For some reason, it works, right? So, since there are 2 hydrogen atoms in the ic acid, so that the net charge for the anion is 2 negative. Alright? So, this is called sulfate. Okay? Sulfate. Right. And this is sulfuric acid. There you go. Alright. So, from sulfate ion, if we remove one oxygen atom, alright, if we remove one oxygen atom from the formula, it will become SO3 2 negative, right? Okay. So, now what is the name of this ion? Can you guess? Alright, that's correct. It is called sulfite ion. Alright, it will become an ite ion. There you go. Okay, so let us erase everything first. No, every annotation. Alright, let me just erase so that you'll see the diagram again clearly. Okay, so from our reference ic acid, an addition of one oxygen atom to the formula, it will become a per-ic acid. From the ic acid, a removal of one oxygen atom from the formula, it will become an us acid. And from the us acid, removal of one oxygen in the formula will become hypoous acid. Same with the oxoanion. Same with the oxoanions. So from 8 ion, an addition of one oxygen atom in the formula, it will become a per-8 ion. From the 8 ion, removal of one oxygen in the formula, it will become an ite ion. And from the ite ion, removal of one oxygen in the formula, it will become a hypoite ion. Alright, so that's it. Now, let's proceed. with the next one. Okay, the hydroic acids. Okay, let me just scroll down. Hydroic acids. So if you notice, what I discussed was about oxoacids. So again, when you say oxoacids, it is composed of a hydrogen atom. Here's an example. Hydrogen atom and a central atom and then oxygen atoms. Alright, an example is chloric acid. Okay, so any acid that has hydrogen, a central atom, and oxygen are called is called an oxoacid. Now let's proceed with the hydroic acid. If we remove the oxygen from this formula, if we remove the oxygen atoms from the formula, it will now become a hydroic acid. Okay, let me just erase the oxygen. Okay, so no, I will not erase. I will just annotate again. Okay, so this is called chloric acid, right? Based from what we discussed a while ago, chloric acid. Now, if we remove all the oxygen atoms in the formula, what will remain is HCl. Okay? When there is no more oxygen atoms in the formula, it will now become a hydrochloric acid. So this will be hydrochloric acid. There you go. So that's how you name acids. Okay, so another example is, let's say you have H2SO4. This is sulfuric acid. And if we remove all the oxygen in the formula, it will become H2S. So it will become a hydroic acid. What will be the new name? That would be a hydrosulfuric acid. There you go. So here are the examples. Okay. Now, these hydroic acids were formed from the reaction of the anions with hydrogen ion. Okay, so just so you know. Okay. Now, let us also discuss about the names of anions in which one or more but not all hydrogen ions have been removed. Okay, so if not all the hydrogen ions have been removed, we must indicate the number of hydrogen ions present. So for example, let's say our ic acid is H3PO4, which is phosphoric acid. Because, let me just reiterate this part. Why do I need to discuss this? Because in the diagram, all the hydrogen ions are removed. Removal of all the hydrogen ions. Okay, that's why the naming is, the naming for the oxoanion follows the rule in this diagram. Okay, so from 8 to per 8 to I to hypoite. Because all the hydrogen ions are removed from the oxo acid, it will become an oxoanion. However, in this case, in this special note, hydrogen ions have been removed but not all. Okay, so from the formula, okay, so from phosphoric acid, if there is a removal of one hydrogen ion, it will become H2PO4 negative. If you notice, H3PO4 has no net charge, right? It doesn't have. But when you remove in the formula, one hydrogen atom, which was yielded as hydrogen ion, it became H2PO4 negative. And the name for this one is dihydrogen phosphate. Alright? So you have to mention how many hydrogen are there, dihydrogen, and the anion, which is phosphate. Okay. Now, if there is a removal again from dihydrogen phosphate with another hydrogen atom, the formula will become HPO4 2 negative. And this one is called hydrogen phosphate. And of course, removal of all the hydrogen ions, it will become PO4 3 negative. And the name is phosphate. Alright? So, there you go. Now, I would like to mention the strong acids. Okay, why? Because, especially if you're working in a laboratory, you have to be careful in handling the acids because they are corrosive, especially the strong acids. An acid is said to be strong if the dissociation is 100%, meaning to say, hydrogen ions is 100% separated from the chloride ions. So these are the strong acids that I would like you to take note of. Okay. What do we call this one? If you listen to what I discussed, since there is no oxygen, it is hydrochloric acid. Okay. And this one, HBr, hydrobromic acid. HI, hydroiodic acid. Now, we have HClO3. I asked you to memorize this one. So, this is chloric acid. So, this is a reference acid. And an addition of one oxygen atom to the chloric acid, HClO4, it is perchloric acid. How about HNO3? It is nitric acid. And H2SO4 is sulfuric acid. So, that's it for today. Again, I would like you to start. If you're gonna study or replay this video, I would like you to start with the reference acids. This one, the reference acids. Okay. I want you to memorize them and then try to navigate throughout the diagram. Okay? So that's it. I hope you learned something today and have a good day. Bye-bye. See you in class.